And onward we venture, scholars. We're going to be taking a look at factoring quadratic expressions. Now, as I was telling you above, I do this a little bit differently than the book does. I actually find this a little bit easier, so I thought I'd share it with you. These are the examples in the first example, so we're just going to be doing the same ones that you're going to see a little bit later. But I'm just going to do it just a little bit differently. Now, this first batch isn't a whole lot differently. I just kind of set it up a little bit different. What I call this is the X game. I just write a little X there. Then I look at my quadratic expression. Oops, sorry. I look at the last number and I look at the middle number. That last number, as you will see in the examples, you're supposed to get a product of that. I want two numbers that give me a product of that multiply together to get that. This number in the middle, I want those same two numbers to add up to that middle number. So I actually put those numbers in my X game. 20, I want a product of 20. 9, but I want a sum of 9. And then I just start asking myself, what has a product of 20 but a sum of 9? I might think of something like 2 times 10. That indeed is 20 when I multiply it. But when I look at 9, well, 2 plus 10 is 12, not 9. So think about it. What two numbers actually multiply together to be 20, but add together to be 9? What's that you say? Yes, indeed. It is 4 and 5. Those two numbers multiply together to be 20, but add together to be 9. So this actually factors into x plus 4 and x plus 5. Now do remember, this X game method only works when there is no number in front of the x squared. When a is 1, or we'll be able to work with when it's negative 1. So let's do the X game again. Now it does get a little bit harder as we get bigger numbers, but it's still the same process. I want a product of negative 72, but a sum of 14. And I think to myself, what gives me that? Now I might think about negative 18, I'm cheating, negative 18 and positive 4. That gives me a product of negative 72. But notice when I add them together, that actually gives me negative 14, not positive 14. But it's very simple when I figure that out. All I have to do is switch the signs. So I don't want negative 18, I want positive 18. And my negative should be the 4. So my factoring is x plus 18 and x minus 4. Now when I look at number 3, I do have a negative in front of it. We don't actually ever want to have a negative in front of the x squared, so we actually have to factor it out. So I'm going to factor out a negative 1, which means I'm going to change every single sign I have so that x squared becomes positive like I want it. The 13x becomes negative, and the negative 12 becomes positive. Now I can play my X game. So, what multiplies together to be 12? Notice now it's positive, but adds together to be negative 13. Notice it is now negative. So I think to myself, product of 12, sum of negative 13. Ironically enough, this is one of the simplest combinations we can have, but a lot of times people overlook it. The two things that multiply together to be positive 12 but add together to be negative 13, does anyone know? Yes, indeed. Negative 1 and negative 12. A lot of times we forget about the 1. But it's the easiest numbers to come up with. So it's -1 and -12. So now I can factor my expression here. I do need to keep on putting that -1. So it's x minus 1 and x minus 12. And that's all there is to that. Now, the next type of factoring gets a little bit more involved, but it does hinge on this idea of the x game just a little bit. So, let me erase my board. I'll put our new batch of problems up, and we'll be right back. And like magic, we have our new batch of problems. Now again, I'm just using the problems from the textbook, but I'm going to be doing it in a little bit different way. A lot of the things that I do in the textbook does are very similar, it's just we set it up in a little bit different ways. So look at 2x squared plus 11x plus 12. You'll notice we do now have a number in front of x squared. So we're now going to have to take that into account. We are still going to be looking at the last number, and in a moment we'll look at the middle number. But we need to first take these first and last terms and actually multiply them together. So 2 times 12, which is 24. Now that I've got that, I am going to look at the middle term just how I looked at it before. I want a sum of 11. But now the number that I want two numbers to multiply together to be is 24. So I will still play the x game a little bit. 24, 11. And so I think about, okay, what multiplies together to be 11? No, make that right. What multiplies together to be 24, but adds together to be 11? And I think about it, and I look down, and I cheat, and I find the answer. Okay? But did you figure out the answer while I was looking? The two numbers are, what was that? 3 and 8. And you didn't even have to look. 3 and 8. Now, with this number in front of it, I'm not done yet. I just don't go and have my factors like I did before. So what I get to now is where I get the name of this method from. It's called the box method. I'm going to draw a little box, divide it into 4 sectors. The number I put here is this, 2x squared. The number I put here is the 12. Now these two empty spots, that's where I wanted my 3 and my 8. So I put 3x, adding that x, and 8x, adding that x. Now I look at my box in columns and rows. And I'm looking for the greatest common factor, the biggest factor that is in both of them. So 2x squared and 3x, the common factor is x. 8x and 12, the greatest common factor is 4. Now I look at my columns. 2x squared and 8x. I've got a 2 common to the 2 and 8, and I've got an x common in the x squared and x. So that's 2x. Look at the final column, 3x and 12. My greatest common factor there is 3. It's a factor of 3, obviously, and a factor of 12. If we ever have an issue with sign, we always keep the sign of whatever this is. But since in this example both are positive, these numbers are going to be positive. Now the box method makes it very easy for you to check your work. Is x times 2x 2x squared? Well, yeah. Is x times 3 3x? Yeah. Is 4 times 2x 8x? Indeed. And 4 times 3 12? Yes, it is. So I actually already have my work already checked right there in front of me. So now I'm ready to write my factors, which are x plus 4. That side tells me my factor. And the other one, 2x plus 3. The sign of the numbers are telling me my operation I should have. Now this is the factors of 2x squared plus 11x plus 12. And we can do the same thing here. So what two numbers do I want to multiply together first? The first and the last. So I'm going to take 4 times negative 3, which is negative 12. I still want my middle number, negative 4x, and that's my sum. X game time. Product of negative 12, sum of negative 3. So again, I think, what gives me this? And what does give me this? Oh, nothing, because I wrote this down wrong. Negative 4 is what I should have wrote down there. So, product of negative 12, sum of negative 4. What is it? Negative 6 and positive 2. But, do I just write that in parentheses? No, we have to go to our box method. Right here in this top corner, 4x squared. In the bottom corner, negative 3. Now I go to my x game, negative 6 and the 2. So that's negative 6x, add that x, and 2, add that x. Now, rows and columns, greatest common factor. 4x squared and negative 6x. Common factor in the numbers is 2. 2 is in 4, 2 is in 6. And x is in both, because I've got an x squared here and an x here. So I've got an x I can factor out. 2x, negative 3. Again, this is one of the simpler ones, but people sometimes miss it. The only common factor here is 1. Okay? No common factor in the 2, no common factor in the negative 3. Let's go to our columns. 4x squared, 2x. Greatest common factor, 2x. Negative 6x and negative 3. Common factor, the 3. No x. But what I tell you about the sign in the last problem, I always keep that sign. So I'm going to make that negative. Again, very easy to check. 2x times 2x, is that 4x squared? Yeah. 1 times 2x, is that 2x? Yeah. 2x times a negative 3, is that negative 6x? Yep. 1 times negative 3, is that negative 3? Yeah. So my factors, 2x plus 1, right here, remember, that 1 is positive, so that's my operation, plus. And 2x minus 3. And I'm all done with my factoring. To me, it's a little bit easier to follow that than what they do in the book. But it is up to you. If after you've looked at my method, and you looked at the book's method, and you think you like the book's method better, heck, I won't know. So use the book's method. But if you like my method, go and use my method. Either way works. So go ahead and go to your practice problems, and good luck, scholars.